All right. I'm sorry to say, Squirrel has walked away from the table again. I thought I had her. I thought I did, but she only participated a few times. We had words, and then she was just like, "No, I demand more for more," and it was bad. I really think she's after my tuna. I don't think this is going to be good. I'm very concerned. Um, that being said, let's take a look at the homework. Maybe she'll join us, but she is firmly on strike at this point. It's a shame. Okay, for number one, what we did, if you notice, we're multiplying by a quarter each time. We start with 2, and then we go to 1/2, and then an eighth. So we're doing it by 1/4 each time. That's the ratio. Now, some of you have been finding it difficult trying to find the ratio. If you are finding it difficult, you can always notice this is not adding or subtracting, it's got to be multiplying or dividing. So you take this and you put it on top of this. So 0.5 over 2, type that into your calculator, and that will tell you what goes in here. For this one, -5 over 5 is 1. For this one, we have -16 over a -8, which gives me 2. And then for this one, it's 81 over 243, and that gets me a third. For 5, 6, 7, and 8, it was extremely easy because it gave you the R, it gave you the A1. You just needed to know where to put them in the formula. On the back, I did number 10 with you. Number 9 was scary because it had that fraction involved, but the numbers were actually, they're long. There's a lot of zeros there, but they're not too bad. Notice for this one, the negative is inside, so we're alternating between positive and negative. Here, the negative is outside, so it's always going to be negative. Negative on the inside means the exponent can change, and it changes with the exponent. Negative on the outside means the exponent, no matter what the exponent is, can't change the fact that it's a negative. And then we started plugging in the random numbers that it gave you, and this is what you should have gotten for those answers. Okay, that being said, I want to quickly talk about what we have learned. Whenever we have a sequence, we can always write it in the recursive form. The recursive form can be either used for arithmetic or geometric. So it can be arithmetic or geometric. It requires the term before it. So if you notice the recursive form, it's really hard to get to A100. Finding A100 would take a long time. We can do it, but it would take a really, really long time. The formula is always A1 equals, and then AN equals AN minus 1, and then whatever is happening to it. So this is where we start, and this is what happens to it, how we get to the next one. That's the recursive form. The closed form is at the bottom. Closed form can also be used for arithmetic and geometric, but there are different equations for arithmetic and geometric. So we're going to say different equations for arithmetic and geometric. There are different types. They are all both on the reference table. And for this one, the closed form, it's easier to get that specific 100 term because you can just plug in 100. So it's easy to get any specific term, easy to find a specific term in the sequence because a 100 equals question mark, just plug in 100 to the formula. So that's the difference between recursive and closed. If we go back to our notes, we always have the recursive form and the closed form. There are two different ways to write a geometric sequence, two different ways to write an arithmetic sequence. So we've got these two different ways to write these sequences. They could be any sequences. And it could be a sequence that has a random pattern or has a more complicated pattern. But we've only talked about two types of sequences. If you go on to Algebra 2, you'll talk about other types of sequences and what they can do. But we've only talked about two types of sequences and two ways to write each sequence. Arithmetic sequences. Let's do an example of arithmetic. Arithmetic sequences would be like 2, 5, 8, 11, 14. It'd be anything that we add or subtract to get the next one in the sequence. And notice there's always the recursive and the closed form. The recursive formula is always going to be a1 equals an equals an minus 1. And then we've got the closed form of the arithmetic. Now, for this arithmetic, if we're looking at this example, a1 is 2, and we are going to be adding 3 each time. That's how we fill in the recursive sequence. The closed form is an equals a1 plus n minus 1d. So that's going to be an equals 2 plus n minus 1, and then we're going to multiply that times the positive 3. Remember, for arithmetic ones, we have to distribute. So a sub n is equal to 2 plus 3n minus 3, or 3n minus 1, if we're combining like terms. So this would be what a recursive formula looks like. This is what a closed formula looks like if we're doing arithmetic sequences. Arithmetic is when you add or subtract. Geometric. Let's do a geometric equation. 6, 12, 24, 48, 96. Geometric sequences are all about multiplying or dividing. All about multiplying or dividing. And once again, we can either write it in the recursive form or the closed form. The recursive form would be a1 equals an equals an minus 1. For this example, we start at 6, and then each time we have to multiply by 2. For the closed form, it's an equals a1 r to the n minus 1, exactly like our homework that we just went over. So an would equal, if we're using this guy, 6 2 to the n minus 1. And for this guy, you're done. So that would be the recursive formula, and that would be the closed formula for that pattern. Now, just be careful for this guy. I want you to draw a little note here, a star. If I were to divide by a number, so if I were to divide by, let's say 5, that would be the same as multiplying by 1/5. All right, this is so far everything that we have learned in the unit. We've learned a lot of stuff so far. That's a lot. What's going to happen is you're going to have a nice little mini quiz. It'll be posted on the Edmodo. You're going to take it just to make sure that we are okay with these sequences before we start talking about fractals, because fractals can get a little bit odd. I love fractals. All right, if you have any questions or if you have issues with the quiz, be sure to message me. Thank you very much. Have a wonderful day. I'll do my best. I'm really not willing to give up that tuna. I'm really not. I'm wondering is Squirrel Cave for something else. Maybe another toy. I can't go to the store. Maybe I can make her a toy. Stay tuned. I might make Squirrel a toy.